when we're dealing with data, because this whole unit is about data, we're going to have two types of data that we deal with. The first type of data is called qualitative. And qualitative data we don't deal with as much. We will occasionally have qualitative data, but it's not going to be our main source of data. Qualitative data is data made up of qualities. Data made up of words or categories. Qualitative data. If I was collecting data about shirt color, I wanted to figure out what was the most popular shirt color. That is qualitative data, because I'm going to be keeping track of everyone's shirt color. Now, yes, I assign a number to it, but the data that I'm looking at is called a qualitative data, right? It's qualities. If I wanted to do hair color, if I wanted to do favorite sports team, these are qualities that I analyze. There are some qualitative data pieces that people get confused and they say, Mrs. Long, I don't think this is qualitative data because it's not a word answer, like shoe size. But shoe size is set specific answers, right? It's a quality. It's not a number value. We'd say how many people wear a size 7 shoe. The number of people would be our numerical value, but the quality is the size of shoe. So we've got qualitative data, which we don't deal with as much. Then we have the type that we're going to deal with a lot, which is quantitative data. Quantitative data, if qualitative data was made up of qualities, quantitative data is made up of numbers, quantities. If I was analyzing the data of how many people rode the bus every day, right? I would count the number of students on buses or the number of adults on buses. Right? I would have different numerical values that represent anything, right? A bus could have 1 person, a bus could have 80 people. Hopefully not. It'd be a full bus. So, these are our types of data. We're going to talk 5 number summary, which is a review, hopefully. A 5 number summary is a way of analyzing data. The 5 number summary is a way of analyzing data. A 5 number summary is made up of
5 numbers.
Nailed it.
Wow.
The first number we analyze, the first thing we look at is the minimum. We can analyze data by comparing, by analyzing, by looking at the minimum in a data set. The minimum, I'm going to put this in quotes because it's not really true, but it's how we think of it, is the smallest number. It's the number with the least value. Smallest isn't a good number, but it's what's stuck in our brain. Smallest means how the size you write something.
Oh.
Oh.
Oh, you mean not the value?
Not the value. But minimum, we're looking for the value, the number with the least value. But we say smallest because it's just a common misnomer.
On a number line?
Good. Lower quartile is the second number in our 5-number summary. Lower quartile, lower meaning the bottom. Quartile, quart means fourth.
Money.
It's the median below the median. It's the middle number below the middle of the data.
Oh, yeah.
Lower
That's like the
quartile
1/4.
is the demarcation between the first fourth and the second fourth. It's the middle of the bottom middle. Number 3 is the median. And the median is the middle value. The median is the middle value. So the minimum is the smallest, the least valuable number. The lower quartile is the middle below the middle. The median is the middle. There's the upper quartile. The upper quartile is the median above the median. And the 5th piece of data is the maximum, which is the greatest, the biggest, but it's not really the biggest, right? Biggest implies size as opposed to value.
Well, congratulations.
So these are our 5 pieces of data that make up our 5-number summary. 5-number summary. The 5-number summary is used to make a box and whiskers or a box plot. Then we have some other data analysis tools. We have some other pieces of data analysis. There are some other things that we're sometimes asked to analyze. There's another thing that starts with the letter M that you can do. The mean. Or sometimes it's called average. The mean, the average, is easily screwed up. Because here's what happens. If I've got a set of data, I take my calculator and I do 1 plus 2 plus 4 plus 2 plus 3 plus whatever the data is. And then I press divided by 10 because there were 10 pieces of data. And I get the answer wrong.
Why?
Because my calculator, if I put in a chain and I do 1 plus 2 plus 3 plus 2 plus 4 plus whatever, divided by
Oh, you gotta put
10.
in the word. You
it's going to divide before it adds because that's order of operations. So the key to doing the mean or the average is to add the data, get the sum, the answer, then divide. We get too much of a roll. We start just moving, and we forget that you have to find that sum first and then divide. It's a common mistake. We also have this idea, so I heard someone say mode. I forgot about that first hour. Whoops. What's the mode? The number, the value that occurs the most. There's some great debate in statistics classes out there. If there are two numbers that happen the same number of times, some people say it's bimodal. There are two modes. Some hardcore statistics would say that there's no mode because mode is the number that occurs the most. Mode, most frequent.
What do we say if there's two?
We typically have bimodal data.
Okay.
There's also this thing out there called the range.
Whenever I hear range, I like it when it's like, yeah, I think I hear
Home on the range.
Yeah. I was thinking more of country roads taking home.
So we've got the range, which is the maximum, the largest value, the greatest number, minus the minimum. We also have something called we have the interquartile range. Inter meaning inside, quartile meaning fourths, range meaning
Range.
subtract.
From like the 1/4 to like the 3/4.
So it is the upper quartile minus the lower quartile. It's the middle half of the data. If I have my quartiles, there's 4 sets of data. The interquartile range is the middle part of the data. And then last but not least, one that sometimes sneaks to the back of our brain is the mean absolute deviation. DEVIATION. The MAD. This comes back from 6th grade, so it's kind of hidden back there. The mean absolute deviation. There are multiple ways to find a mean absolute deviation, but the words mean absolute deviation mean as follows. Mean is the average. So there's going to be some form of taking the data, adding it up, and dividing by a value. Absolute value, it's the distance something is from you. And deviation is the change, right? So it's how far away. What's the average amount that it's away from something else. So there are multiple ways to do this. You can find the MAD, the mean absolute deviation, for the mean, for the average. You could find the mean absolute deviation for the median. You could find it for the minimum. You could find it for the maximum. To do this, you first find, and we're going to do it by finding the median. or the mean, or the lower quartile, or the upper quartile, or the maximum, or the minimum, whatever it says. We're going to do it for the median. But you could do it comparing to the average, the mean. So then what you do, we find the value that we're going to compare everything to. It's our perfect number. Sean and Maritza, are you listening?
Yes.
Okay. You find the absolute value for every piece of data and its distance from the median. So if we're finding the mean absolute deviation from the median, the first thing I do is I find the middle number. Then I'm going to look at every piece of data. And I'm going to say, if my median is 10, and I have a piece of data that is the number 11, how far away is that from my median? 1. And if my other piece of data is 9, how far away is that from my median? 1. I'm finding the absolute value of the distance each piece of data is from that desired number. And I write them down. Well, it's called the mean. So what are you going to have to do? Find the mean of these numbers. Again, my personal preference, Mrs. Long's personal preference, is that we find the mean absolute deviation from the median. You could find the mean absolute deviation from the mean. You could find it from the lower quartile. You could find it from the upper quartile. 5-number summary. These are our other data analysis items that we've used before.